Hello. Welcome to this video on key features. This is the third day or the third piece of key features that we're covering in Math 1. I hope you had a good weekend. Yeah. Well, okay, today we're going to go ahead and talk about end behavior, and our objective is to identify end behavior of different graphs. The two types of graphs that we're going to be working with are linear functions, specifically, right, straight lines, and exponential functions, which, right, either they grow or they decay, or some sort of image like this. If they're flipped, they'll look similar to this. I swear that's exponential decay. Okay, and what end behavior is it's just behavior in the end. I always think about the Linkin Park song, right? In the end. So make sure you get down to our objective, and we'll move on to prior knowledge. All right, so activating your prior knowledge, here if I have an exponential functions, we want to be able to identify all of these key features, and I'm just going to kind of jog your memory about these. So remember, domain is just my my x values, right? So all of these values where this function exists. And if you're having trouble with it, imagine squishing this graph, right? If I push this graph up to here, up to my x-axis, doesn't it have an arrow going in this direction? And then if I kind of push it down, right, it has an arrow going in this direction. So my domain is going to be all real values. So from negative infinity, right, an arrow this way, comma, positive infinity. And remember, we always use parentheses with infinities. We do not include those values. Range, these are my y values, and the range, right, I have an arrow. If I was to squish this to the y-axis, it goes up, and from the bottom, if I was looking at this, it has an arrow, but this one, remember, exponential functions have asymptotes. So this function actually has an asymptote. I'll put it in, let's do green. Has an asymptote here at -7. So this function can never cross it. And when this function can't cross this, this affects my range. So the range goes from -7 up to positive infinity at the top. So therefore, I have -7 to positive infinity. And I don't include the -7 because it never touches this value, right? It's never going to be -7. And that is my asymptote. X-intercept, here I have this one, pretty easy, -6, 0, and my y-intercept at 0, -6. Is this function increasing or decreasing? Well, as I go from left to right, it's certainly going down, so it's decreasing. And then here is the difficult one, the positive and negative. When is my function positive? When is it negative? Well, remember, it is positive when it's above the x-axis, so it's positive going this way, and we use domain values to discuss this. So it's positive from, well, negative infinity all the way up until this value here at -6. And we don't include it because it's 0 at -6. And then when is my function negative? Well, it's negative when it's below the x-axis, starting at -6 all the way out to infinity, right? So at -6 all the way this way, it is negative. So we would say, so from -6 to infinity, it is negative. Okay, our objective today is students will be able to identify the end behavior of different graphs. End behavior is a description of what happens to the values of f of x of a function as a function f, as x goes to infinity and as x goes to -infinity. So please fill this in your notes. And what I'd really like you to kind of add to is as x goes to infinity, well, my x values are here, and as x goes to infinity, that is this direction. That is the right. So right below x goes to infinity, I'd like you to go to the right. And as x goes to -infinity, -infinity exists out here. This is the left. And that's generally what it's saying here. So what happens to my graph as the graph goes to the left and as it goes to the right. And generally what you're going to have is it's the three cases. You have three cases here, which I would actually like you to add in below the graph. We have three cases here. One, my f of x values are going to go up to positive infinity. They're either going to go down towards negative infinity, or they're going to go to an asymptote, which is some value in the middle. Okay, so that's what this says. F of x can approach infinity, negative infinity, or a number. We're generally going to get these type of cases, especially with linear functions. So if I have an arrow going this way, where are my x values going? Well, they're going to the right, and that is positive infinity. And where are my y values going? Well, they're going up, and that is positive infinity as well. If I have an arrow going this way, my x values are going to the left, correct? I'm going to the left, and my y values are going up. Well, left is negative infinity, and up is positive infinity. If I have an arrow going this way, in my third quadrant, my x values are going to the left, which is negative infinity, and they're going down, which my y values are going down, which is negative infinity. If I have an arrow going in this direction, towards my fourth quadrant, my x values are going to positive infinity, and my y values are going to negative infinity. I would also like you to write in your notes in this section, please add positive infinity up here, negative infinity down here, positive infinity over here, and negative infinity over here. And actually in parentheses, I want you to write up. Parentheses down here, I want you to write down. Over here, I want you to write right. And on this side, I want you to write left. Okay. So let's look at some examples. The first example here, we're going to be asked to write domain and range. With linear functions, I have arrows going in both directions. My domain is negative infinity to infinity for linear functions. Linear functions always have a domain of all real values. Additionally, they have a range that includes all real values. Right? I have an arrow going down, an arrow going up. They exist for all real values. So end behavior. End behavior always has as x goes to negative infinity and as x goes to positive infinity. So as I go towards negative infinity, and remember this is the left, so as my function goes to the left, where are my y values going? And I hope you see as I go this way, my arrow is going down. So it's going down, and when my arrow goes down, that means f of x goes to negative infinity because I have negative infinity down here. So as I go to the left, my y values go down. So that's what this is saying. Then as x goes to the right, we always have a left and a right, always. Okay, so as my x values go to the right, where are my y values going? Where's the graph going? Well, my y values are going up. They're increasing. So we would say f of x goes to positive infinity. Okay, so again, remember what happens as I go left, what happens as I go right. Here, this one you're going to do, I want to remind you that the domain for linear functions is negative infinity to positive infinity, right? This graph, it doesn't stop at any point, it continues, and the range is also negative infinity to infinity. But I want you to do the end behavior on your own. Remember, always we have as x goes to negative infinity, we want to describe what happens to y. We want to describe what happens to f of x. And as x goes to positive infinity, what happens to my y values, right? So, sorry, equals. Okay, so as x goes to the left, what happens? And as x goes to the right, what happens? Please pause the video and fill in these two values here. That's what I want you to fill in. Okay, hopefully you've tried this. And as x goes to the left, I have my y values. Are they going up or are they going down? Well, I hope you see they're going up in this direction. So I'm going to write positive infinity. As x goes to the right, where are my y values going? My y values are going down, and that direction is negative infinity. Okay, so now I have an exponential function, and the domain for exponential functions, again, same as linear, is all real values. It is negative infinity to positive infinity. The range, however, is not the same as exponential functions. It's not all real values because exponential functions have, I'm not sure why it's doing this, so not letting me write. They have an asymptote, right? And I have an asymptote here, meaning my graph will never go below 1. So that affects my range, right? My range is now 1 to positive infinity. Okay, but for end behavior, it's still the same case that we're going to go to the left and we're going to go to the right. So what happens as I go to the left and what happens as I go to the right? Where do my y values go? My f of x values. So f of x, where do they go? So let's start with the right. As I go to the right, what happens? Well, as I go to the right towards positive infinity, my values go up, which means they go to positive infinity. Now I'm going to go to the left. And if you remember back a couple of slides, we said, if I can find it, here we go, f of x can approach positive infinity, right? That's up. It can approach negative infinity, that's down. Or it can approach a number, which happens to be an asymptote here. So if I go all the way up here, so if I go to the left, is my function going up, is it going down, or is it approaching an asymptote? And I hope you see that it's approaching this asymptote here. And in this case, my asymptote happens to be at the value 1. Okay, so as x goes to the left, as it goes towards negative infinity, the y values approach my asymptote at 1. Okay, I would like you to go ahead and do this problem. Again, remember, domain is negative infinity to positive infinity. It exists on all real values for exponential functions, and my range is affected. Here, my range is affected by the asymptote at negative 1. So I have an asymptote here, which means my range is negative 1 to positive infinity. Okay, please go ahead and do the end behavior. What happens as x goes to negative infinity to the left, and what happens as x goes towards positive infinity? Where do my y values go? Okay, so go ahead and pause the video and try this one on your own now. Alright, hopefully you've tried this. To the left, everything we own in a box to the left. As we go this way, we happen to be going up towards positive infinity. And as we go to the right, my y values don't go up, or they don't shoot up, or they don't go down. They're actually hovering at this asymptote, and this asymptote is f of x equals negative 1. So therefore, my y values are negative 1. Okay, and that is end behavior. Pretty simple. What happens as I go to the left? Do I go up, down, or towards an asymptote? What happens as I go to the right? Is it up, down, or an asymptote? Okay, and our closure is what happens, what does end behavior, what is going on? What does end behavior describe? Okay, and again, I just talked about this. End behavior describes what happens in the end, right? To quote Linkin Park. All right, don't forget, like my video, subscribe. I hope you have a wonderful day, and Schwarberg is out.